Can you hear me? I'm not sure if, oh yeah, this is working. Okay, great. All right, welcome back everybody. I hope you had a nice little break with some cake and coffee and tea, and you are ready for our next session. I am super excited to introduce our next guest, Nox. Rogelio Nox is coming from Singapore. So I am really happy to have you and also impressed that you are standing on the stage after traveling for so many hours. But I'm coming from the other side of the planet, so we're kind of meeting in the middle. So Nox has been the lead of the core platform engineering and innovation team at Standard Chartered Bank. And he's been working with Axon framework specifically for the past 6 or so years. So he's had a lot of great experience working with our product and also other stacks out there. So really happy to hear your experiences and what you have to say. So
All
with
right.
no further ado, Nox, everyone.
Thank you. Thank you. Hi, and good morning, everyone. I'm really happy to be here. Yeah, I think the journey with using Axon has been interesting, to say the least. Okay, so today I'm going to talk about the lessons we've learned, not just building with Axon, but how do you create applications with a keen focus on operational resiliency. So just like to ask, anyone here works in the finance industry, banking? Oh, cool. So very good. I hope you find this talk useful. All right, so let's get started. So about me, I'm based in Singapore with my wife and 2 kids. Yeah, the previous speaker I saw also like in similar lines, and I think it's kind of funny. But yeah, I was trying to think of a joke, but I might end up washing dishes for a week, right, when I arrive home. So I've been working in the industry for more than 2 decades now. I started my career as a system administrator. I was dealing with Unix systems a while back, and this was the time when the industry was around internet service providers, so billing systems and all that stuff. And I joined Standard Chartered around 2007, 2008 in the trade finance domain, and I'd been there for a decade and a half now. Yeah, and today, as Sarah mentioned, I'm managing the core platform engineering team, and my main customers basically are the developers. So we build and maintain the platforms that they run their applications to, and take care of the other stuff or the ecosystem around enterprise applications. Okay, so enough about me. Let's get started. So what is TradeXpress? So TradeXpress is the application that we've recently gone live in June in Singapore, and it's a microservice architecture. It's designed to be straight-through processing, so anyone who is in trade finance, I think, would know that the way the transactions are processed are traditionally very manual. You know, a customer or client would come and then with a bunch of documents, and then you'd have to process that in a manual fashion. So most of the systems were designed that way. You have a maker and a checker process. So straight-through processing means that you kind of flip that and then design the system to do straight-through processing first, and then only do manual processing when exceptions are triggered. So that's how we had built and designed TradeXpress. Yeah, so we do the. We're also one of the first applications to use the bank's new infrastructure as a service. which is with good collaboration from our counterparts there, it's basically ensuring that the application can run on multiple service providers as well as on-prem. Right? So this is about standardizing the way we deploy our apps, regardless of the service provider. And since we were talking about resiliency, this also means that the redundancy of the system is taken into account since day one. Okay, and this talk would, as we go, would go through some of these scenarios and the lessons that we've learned. Okay, so this is how our tech stack looks like. The blue boxes on top is what primarily comprises TradeXpress. So you have your UI, you have your workflow, you have your integration services, you have your operational data store, you have your reference data, and at the middle is where the processing happens, and that's where we use event sourcing, because if so trade finance, right, it's heavily around life cycle management. So in simple terms, it's like a loan. Basically, you apply for a loan, you create a loan request, and then you get a financing, right? So your loan gets financed, and so trade finance is like that. So it fits naturally into the event sourcing kind of pattern or architecture. And the other layers are infrastructure services. So this is about separating the business from the infrastructure. So we'll go through some of the details about this as we go through the talk. Okay, so when you try to embark on something like building an enterprise app, right, you had some kind of vision, how your journey will look like. So when I started, we still have like a mainframes and bare metal, right? And then after a few years, and virtualization become the norm. You have your virtual machines that become available. It's still not as instant as the cloud-ready or the cloud type of infrastructure, but it's way faster to provision a VM than a bare metal box. And then we started dabbling in with microservices. This is also the time when Spring Boot, right, become quite how to say this. The developer adoption of Spring Boot was around this time, and I think the way I view it is that one of the reasons probably that Axon has captured a lot of the event sourcing developers is I think from day one they managed to integrate with Spring, and the other options at that time were not integrated with Spring. So this made the transition to event sourcing a lot more easier, at least from my perspective. And so when we started, we're somehow in the middle of cloud ready and then cloud enabled. So cloud enabled means so that's the ideal state where we could deploy our applications to any of the cloud service providers, and at the same time also deploy it on-prem. Because not all the countries, for example, would allow you to put your applications in the cloud, at least from our perspective. So with all of this, right, we had some experience with running containers and Kubernetes. So when we started a project, we've got this, all right? So we say if we had a good feeling about starting this, and we're quite confident on embarking on this journey. Anyone here is a fan of Star Wars? Okay. I've never been to a developer conference with zero Star Wars fan, by the way. Never. So that's always good. Okay, so how do we define operational resiliency, right? So for us, it's a combination of your disaster recovery, your availability, and the ability to also cater for stressed exit and non-stressed exit. So what are these terms, right? So you have five basically major categories. The first one is service or component loss. And this is about your application or part or components of your application. So if you have something like application running in Kubernetes, then if one of your pod dies, then you probably have more than one replica. So you're able to accommodate the scenario. Site loss is basically your data center. So if you have two data centers, then one goes down, then you'll have another one to serve the request. If you are on the cloud, most of them would have at least three data centers or availability zones. So one goes down, you have two. The third one is geo loss. So this is basically a scenario where the entire region goes down. Then what do you do? And the fourth and fifth is more on supplier loss and suppliers. This is your cloud. When we say supplier here, when I say supplier, this is the cloud service provider, right? So what happens when you want to move out of the cloud service provider, both planned and unplanned? Okay, to drill with it further, so if you go now to service and component loss, so if it's an application, as I mentioned, you have a pod and then you have replicas of it. Then if one of the pod fails, then you have, if your replica count is 3, then you have at least 2 more pod, right, to serve the request while Kubernetes will try to spin up another pod for you. So depending on your replication, and this is mostly automatic, depending on how you had configured your liveliness and health checks. Now, when you go to EKS or most of the Kubernetes implementation or AKS, they would also have something like auto-scaling groups, right? That you probably would define, and then depending on how you slice your or do your tenant design, you probably would be able to also say, okay, if one of the nodes, right, the worker nodes goes down, then spin up another. For various reasons, this could be both planned and unplanned, meaning you might do some recycling or updating the operating system. And cloud service providers do this very, very often, by the way, and you have to accommodate for that without impacting your application availability. And then you have, of course, from one of the components is Axon. Then you have your Axon cluster topology, where and this is based, of course, on context, not necessarily based on the node. So if one of the context leader is down, then it will be picked up by another active node, right? Depending on your configuration. Then we also have OpenSearch or Elastic. So same applies, and most of this, I think fairly most of the cluster type of backing store applications nowadays have some sort of similar mechanisms for addressing when one of the node goes down, right? You have OpenSearch, you have master, and then the other guy comes the next one, and then you have Kafka, of course, leader and follower, and then Postgres with your primary and secondary. So if your primary goes down, the secondary, depending on they also have a concept of priority, what you want to do, and then the secondary server comes up in case your primary goes down. Of course, there are other uses for it. You can also do it to redirect your reads from secondary nodes in terms of Postgres, but in this context, we're talking about what if the node goes down. Okay, so site loss. So site loss is basically when, I think back in the day, you would normally have only 2 data centers, right? In most settings, you have active or passive or active-active. In the case of the cloud, you normally would have 3 in most regions. So that would mean that you can afford to have, and these are geographically separated, I think 20 or 50 kilometers if I recollect correctly. So site loss means the ability to still operate even one of those data centers or availability zones are down. Yeah? And one thing that we learned about site loss is that it's difficult to simulate. Region failure is easier to simulate than at least for the cloud. And the reason for this, most of the components are because if you remember you're a tenant in a cloud service provider, you can't ask them to suddenly shut down one of the ACs for you. So you had to think of ways how you do it. Maybe you start labeling your nodes and then saying, okay, if this node is belonging to availability zone 1, then kill all the pods and terminate all the pods in that availability zone. But some of the components are, and in the case of Axon, for example, then you have to look who is the current leader, and then for the simulation that you're doing, and then you have to do that. For Postgres, for example, then you have to also look at that the primary is running on the same availability zone that you have to simulate. So it gets up, and there are some components like Kafka, for example, where there really is no way to simulate it, because even if you put the other one down, then the other 2 would still function effectively. There's no, how to say this, the failover is not something that you'll be able to achieve. But yeah, you can do to some extent, but this is one of the lessons that we've learned. Okay, now when we go to, as I look, all right, we went into this with having very good feeling that we know what we're doing, but yeah, but this is true, right? It's not what you don't know that usually gets you in trouble. It's what you think you know, but it's not true that gets you in trouble. So, and this is when we come into now the disaster recovery. So when we started, we were just looking at a region, right? And then the assignment was that we were, or the problem statement, then what if the region goes down? Then you kind of think, first you think, could it really happen? Could a region actually go down? I think in most scenarios, you probably would have a component of the region failing. Maybe your Elasticsearch, right? That VPC cluster would be down, or your Aurora, or some of the components. But it's in the entire region failing. It's not something I've searched the internet for examples of this, and there's not many that I could see. But if you have to really look at the problem deeper, yes, it could happen. It could potentially happen. It could be a cyber, or the cable could be, accidentally be stopped, from, or if you don't have redundancy in your data centers. So the answer is yes, it could happen. And what if it happens? Although it's a very unlikely scenario, the answer is still, what do you do? So AWS has published this, which is a very good, I think, way of assessing what options you would like to take in case of a region failure. And this all depends, right? On the left you have, on the right, sure, but you have your backup and restore, which is a lot more manual, but in terms of cost, it's also the lowest. Right? So meaning if your region goes down, you take all your backup and then restore to another region. But the impact of that is that you probably have a longer recovery time because importing backup and all of that, right, takes time. Then you have pilot light. So this is like the kind of a middle ground that you can take, which on the other region, you keep just a fair amount of infrastructure. So that, for example, in the case of Kubernetes or EKS, then you just maintain the control planes running. You don't have the worker nodes, but but that would be far more faster than trying to spin up a new cluster from scratch. The next one, of course, is warm standby. And this is basically having a mirror image of your infrastructure. So if you have 2 regions, then if you have 10 nodes here, you also have 10 nodes there, as opposed to pilot light where you have 10 nodes here, but 0 nodes there, but only having the control plane. Okay, and the last but not the least, the most expensive one, of course, is you have active-active. Your traffic is always, your backup side is always ready to serve the infrastructure. It's fully up and running. Okay, so when we started doing this, then we started thinking. So remember, in a system like this, it's the ecosystem really that you have to be aware of. So in the case of Axon, for example, right? If you try to think, if the region is down, then what would happen? So, and your application is not just reliant on Axon, right? You would also be relying on the ecosystem that it uses. So in this case, I'm giving an example of let's say, Aurora, right? Then what do you do? One thing also about service providers, right, is that you would think that if you have Aurora, for example, and the service available across the regions. So that's what we have learned as well. It's not. So initially, it's like Singapore and Hong Kong, for example. And then found out that Hong Kong doesn't have Aurora Global running there yet. It's not a service that's been offered there yet. So what do you do? So that's the reason why in this example I'm giving Singapore and London. So the latency between Hong Kong and Singapore, roughly I think 40, 50 millis round trip, and then for UK or London data center, that's 250 to 300 millis, I think, right? So you have some options here. Either you make your Axon DR side as also an active backup, where all the commits are also acknowledged by the failover side, or you make a passive backup option. And if you wanted to do pilot light, then this is probably one of the options that you'll take. And when you do that, then you come up with a scenario like this, right? That you have 2 types of data lag, I would say, or replication lag. One is that from Axon to Axon, because you have configured it as passive. Then that's the first lag that you'll encounter. And then the second one is from your projections, basically, right? One thing to note, though, and this sometimes confuses, creates some confusion, is that even on the primary side, the event handlers will always come last, right? Your commits will always happen first on your event store. So that means by the time by the nature of the event consistency, eventual consistency, that means that your databases, right, or your projection, whatever you're using, is always going to become, it's always going to come after, right? So that presents a problem in some cases. And the other one is also the telemetry. So this on the early testing that we've done on disaster recovery is what we've found out. So if you simulate that the region is actually down, then you go to the next region, then the question is what metrics are you going to pull off if you're not extracting data from both regions? And this is important because you probably would want to know the state of your clusters. So imagine if you have like Grafana or Prometheus, you're trying to extract it from region A, which is your primary region. So what I mean by cross extraction is that you're going to extract data from both region A and region B. And on region B also, you're going to extract data from region A as well as region B. Because you're not, if the region is down, that means even your telemetry is also down on the primary region. I hope that makes sense. And when you have that, then you would end up with a scenario like this, right? And so the first scenario is that and the most likely scenario is your token on your event store is ahead, right? And then your view database or your projection, your Postgres, is behind. So Postgres, Aurora, global Postgres, they don't do like table replication. It's basically volume replication, right? But it happens outside of your event source system or event source server like Axon. So in the most likely scenario you'll face is scenario 1. So, and we'll go through what are the options that you have when this happens. The other scenario is, although highly unlikely that will happen, is a potential thing that could happen, wherein, let's say your backup node is down, and then you have like and your database server, of course, is replicating because it's a different service, and then you have a region failure, right? Then what would happen? Then you had your data, basically the state on your database is ahead of the state of your event store. Yeah. So how do you? What are the things that you could do to address this? So first one, of course, is observability. You know, prevention is better than cure. You probably want to set up alarms. You know that if you see that your token, right, are not matching what you have on the primary and the secondary region. And then when this happens, the first thing that you do, you compare. That's why it's important that you have the telemetry on both sides. Then you determine whether it's scenario 1, Axon is ahead, and then your projections are behind. Or do you have a scenario where your projections are ahead and then your Axon is behind, right? So in the first scenario, it would be your typical scenario when you have Axon running, wherein your event handlers will start catching up. Of course, you do need to handle idempotency because some of the messages, right, would probably be a duplicate, and you have to handle that. But the second one is a little bit more interesting. So remember, in most cases, you probably would be receiving the intent, right, from another upstream system or from a user, right? So and in the case if you have a different upstream system that already has a record of what transactions that they had sent out to your region, to your application, and that's important note to take into account when you're doing a failover, because then you would be able to say, oh, okay, out of 10 that was sent to me, I processed 10. Or out of the 10 that was sent to me, I processed only 8. Right? That means there's 2 that probably you need to reprocess. And this all depends on your RPO and RTO SLAs. But the key thing to note is you always would want to have, or you would always aim that your state is, to reset back to a known state. So either you, for example, you take a snapshot and then say, okay, take a backup of the secondary database, and then you rewind it, from maybe 15 minutes before your event store check. Or if your RPO is, let's say, 5 minutes or 10 minutes, then you could probably say that, okay, yeah, I can reset my token to the same position, right? You can do your token reset to be the same position as your event store token. So this would work for your event handler. You would do that. But there are different behaviors. If you go with a Saga, for example, and you have something stateful there, if you reset it, that would also start at, there's no replay, it won't. So that's the difference. If you remove the token entirely from your event handler, then it will start replaying from the beginning. Whereas if it's a Saga, if you remove the token, then that would go into the last position, known position in the token. And accordingly, then you have to handle the same. Considerations. So you need to have a minimum of 2 in your DR at least, because if you have to accommodate things like AMI refresh, which is a common thing in the cloud. The concept of patching is no longer there. You don't take a operating system and start patching it. What you would normally do is you would decommission or remove that instance, and then out comes a new instance, and then you have to redeploy. Now, during this process, if you only have one on the secondary region, then your potential for data loss is higher, because there's no guy receiving the data on the other end. There's no node receiving the data on the other end. So you at least need to have a minimum of 2. The second one, of course, is having it on multiple locations, right? And if you have a location where latency is far more acceptable, you probably would want to have an active node setup. That way, you always end up with scenario number 1. Okay. I hope that makes sense. And yeah, so if we put that into the same type of diagram as I've shown before, then it basically means the whole region is down. If you're doing pilot light architecture, you keep your EKS nodes there with your control plane. Then you do asynchronous replication of your data from your primary to secondary. And there are also various mechanisms of doing it. If I think you can now do headless type of replication, even for pilot light, meaning you don't even need to spin up the server and just have the data. And then when you wanted to revive the region, then you spin up the instance and then connect with that data store, right? That probably has an implication on cost, because then you don't need to maintain the running instance. Yeah, so the rest of the components would be in similar fashion. Now on supplier, and this is more like planned or unplanned in terms of cloud service provider engagements. So stressed means that suddenly you need to get out of your cloud service provider. So you need to have alternate options, whether that's on-prem or another cloud service provider, right? And then the second one is a planned migration. Maybe it's more of strategy, or you want to exit from another cloud service provider, or you want to go back to on-prem, and then you would need to have the similar, a similar type of infrastructure. So it's really, really important that you separate the infrastructure from the business, right? That the way you design your application can run on multiple of these, and you have to test it as well. Okay, so just to recap, so the first thing is the familiarity with what the service provider is offering you. The example I've given, like Postgres, and because that dictates or that assigns you that guides you on what regions to use or what strategy to use, whether you want to do active-active, you want to do pilot light. Then the next one is the parity of the service components. Oh, sorry. So the parity of the service components. I'll make it faster. Yeah. So and then the event sourcing scenarios. What else? Important thing is the game day thing that you have to do, because a lot of these things, right, are good to do as a paper exercise, but it's really, really different when you try to do it in real life. And you have to think not just the technology parts of it, but also even the people side of it. Because when a region goes down, then you would need to know who to call, who to raise ticket to. All of these components gets quickly fleshed out. So a game day for us typically would mean that everybody goes into, now it's virtual, go into the same room or channel. And then we start simulating it and then trying to note down what everyone needs to do. And then start journaling. What are the issues, right? Or how long did it take to restore Postgres? How long did it take to restore EKS? It's important, for example, the configuration could drift very, very easily if you have 2 regions. So that's one consideration as well. You're probably maintaining the primary region up to date. But that application is changing. It might have 3 or 4 releases already, or 5 or 10, or maybe in a span of a year, more than that. Then suddenly you have to go to another region. Are the keys there still valid, or the certificates already rotated? So stuff like this. Then telemetry, very, very important if you're doing operational resiliency, because of the scenarios I mentioned. And this one, S3 would help you in a sense. I just want to stress the configuration. So based on my experience, it would be better that on the separate region you actually maintain 1 or 2 nodes, just to, let's say if you're using cloud config, just to maintain that up and running, so that when you do fail over, then there's less chances that your configurations are stale. Okay, with that, I'll give up the floor for questions.
Thank you so much, Nox. There's actually one question on, here we go. When a cloud region fails, a lot of applications will try to fail over all at the same time. Can we rely on cloud providers having enough computing power to handle that? Do we need to be active or possibly be locked out?
Oh, that's a good question. So it depends. So I'm not sure about other applications. I'm not sure who asked that. But in the case of this application, for example, or applications that I know of, the systems are a combination of on-prem and then cloud, right? Not all the systems are moved to the cloud. So that makes the scenario a little bit different. Now on the compute side, it depends. So if you really want to guarantee, let's say your other DR region has the same capacity, then you can reserve those instances. Of course, there's a question of cost, but that is possible. If you want to guarantee capacity, there are ways on Google, on Azure, on Amazon to guarantee that capacity. It's always a question of cost. Okay, any other question? All right.
If there are no questions right now and you think of a question later on, please do add it to this session slot. It has a spot where you can add your questions. Or just catch Nox afterwards and
Sure.
have a conversation. We're going to take a 10-minute break, and we'll see you all at the next session. Thank you so much, Nox, and thank you everybody for joining.
Hope you learned something.